Friday the 16th of February. The moon is probably in its 7th day. It's right overhead. Did a little bit of looking at it earlier at higher magnification. Zoomed a bit on it in Jupiter. Not enough detail visible on Jupiter to make imaging worthwhile. However, the moon did look pretty good. I had also synchronized the scope to Rigel, and now we're looking at Betelgeuse. I may go to color mode. What I'm going to do right now, however, is I want to scope out some galaxies beginning with NGC 1700 plus. What I want to do is I want to get a sense, because I am now figuring out that average surface brightness is really killing you when you go the magnification route, which was predictable, but I didn't realize how bad it was going to be. We won't get much of an opportunity to explore in-depth imagery tonight due to the presence of the moon, but the sky is quite nice. I can see the dog star Sirius flashing in the distance, but it generally does that. So stability's not particularly good, but transparency is, although the moon is illuminating quite a bit of the sky. I'll be synchronizing to Betelgeuse here in a second. Then I want to push through and look for, I think I'm going to go with sub-11th magnitude galaxies this evening. If I can get a half dozen in to a dozen, beginning at NGC 1700s thereabouts, that should be a nice test. And then I'll go back into color mode to see whether or not it really is worthwhile using infrared sensitivity and losing color in terms of galactic images, which I suspect is the case. We won't get as deep with galaxies in color mode, but hey, test, verify, validate, move on. I am hoping any galaxies we turn up this evening will be revealed somewhere within the very bright luminous disk of Betelgeuse as I now synchronize the mount, and let's head out. As it turned out, our first study of the evening on my list turned out to be NGC 1700, a galaxy in Eridanus. Magnitude 11.23 by 1.8 arc-minute, elliptical class 1, so very close to a perfect sphere. 173 million light years distant. We're at minus 5 degrees. Now, one thing we're going to learn about all elliptical galaxies is they're not going to show much more of the bright core and a faint aura on the outside. And that's pretty much what we're seeing here. So magnification isn't really necessarily going to help us much, nor is demagnification going to help us much, because magnification is going to dilute out some of the fainter components, and demagnification is just going to render it on a smaller scale. But that's a look at magnitude 11.2. Probably average surface brightness, we'll add another 2 to it, 13.2 and 1.5, 15. So I'm assuming that at 150x, average surface brightness galaxies 15 and brighter will reveal something of their structure. But in the case of elliptical galaxies, that structure is just stars and stars and stars fading off into their limits. But that's not a bad view for a 7-day moon. Now, I picked this galaxy out because it's pretty faint. It's NGC 1717, a galaxy in Orion. It's also NGC 1719, magnitude 14.5, 1.1 by 0.3 arc-minute spiral with a lowercase a, z plus 1, 185 million light years distant and very close to the celestial equator. The galaxy was quite apparent when I first looked at the screen. In this region right about here. Not bad for 14.5 magnitude on a 7-day moon. It does show some aspects of elongation due to its 1.3, roughly 4:1 aspect ratio display. Not bad. Here I think we are getting a view of NGC 1723, galaxy in Eridanus, magnitude 12. Largest, 3.3 by 2 arc-minutes in size. Spiral with a bar and a ring, 168 million light years distant. We're at minus 11 degrees in declination. And the one good thing about being further south is we are further from the moon. NGC 1726 is another galaxy in Eridanus, magnitude 11.7, 2.1 by 1.5 arc-minute. Lenticular spiral, Z class in terms of evaluating its evolutionary sequence, not its shape. 178 million light years distant. We're at minus almost 8 degrees in declination, with right ascension almost 5 hours spot on. Now on to NGC 1752, another galaxy in Eridanus, magnitude 12.4, 2.6 by 0.8 arc-minute. I do believe it's right there on the screen, although I'm looking at an angle. I hope I didn't disturb its presentation. Spiral with a bar in lowercase c, so 3 times removed from the lenticular Z class, 158 million light years distant. We're at minus 8 degrees. And you know, we're seeing more of galaxies tonight than we did several nights back when the moon was not an issue. But, of course, we're only looking for brighter galaxies, so I am going to look for a 15th magnitude galaxy. I know we saw 14.5 earlier at 150x. Normally, in a decent part of the sky with no moon, we should be able to reveal 16.5 magnitude galaxies at 2 millimeter exit pupil 75, and 15th magnitude galaxies at 1 millimeter exit pupil of 150. But I do want to explain more about exit pupil as we progress. NGC 1784 is a galaxy in Lepus, the Hare, magnitude 11.7, largish, 4.1 by 2.6 arc-minute, so oblately presented spiral with a bar in lowercase c, which means it should have a fairly I would recommend a fairly small BV delta, or what is known as the BV index, of maybe 0.6 magnitudes. We're at minus almost 12 degrees in declination, and the galaxy is visible right about there on the screen, although it does look like a bit of a smear. And there are smears associated with the stars here. So, As an aside, I thought we'd have a look at NGC 1788. It's a reflective nebula in Orion. 5 by 3 arc-minutes, 1,300 light years distant. We're at minus 3 and almost a half degrees in declination, and I do believe the nebula may be present about there, but I'm seeing smearage once again on the screen. Okay, what we're looking for here is a 15th magnitude galaxy, which I believe at 150x on a 6-inch scope, even though we're using the equivalent aperture of about 12 to 15 inches, is 1 millimeter exit pupil magnification. The galaxy is NGC 1799 in Eridanus, magnitude 15, 1.1 by 0.6 arc-minute lenticular spiral, a 200 million light year distant galaxy, which is probably about 70,000 light years in diameter. We're at minus 8 degrees in declination. I do believe the galaxy is turning up, but I hate shifting around. Doesn't appear to be any smearage, but this is where we would expect to see a galaxy, and it may be seeing it. So I am quite impressed. 15th magnitude galaxies is defying my expectations, especially for a 7-day moon. NGC 1819 is a galaxy in Orion, magnitude 12.4, 1.7 by 1.2 arc-minute, spiral with a bar, but a lenticular with a bar, 200 million light years distant. We're at plus 5 and change degrees in declination. What I'd like to see in this galaxy is basically get a sense of its footballish shape, but also the bar that should cut across its major axis. Something to look for on the morrow. Now we're off to NGC 1832, a little further south in the Hare, Lepus galaxy, magnitude 11.3. Smallish for 11.3, 2.3 by 1.5 arc-minute, spiral with a bar, BC, which means 2.5 times removed from lenticular class Z. It also has a ring. This galaxy is 85 million light years distant, which puts it at about 60,000 light years in diameter. We're at almost minus 16 degrees in declination. I do believe the galaxy is present right about there on the screen. I've selected NGC 1886 a galaxy in Lepus, despite the fact it's almost minus 24 degrees, because it's magnitude 12.8 with a 3.1 by 0.4 arc-minute aspect ratio, which means it's pretty much edge on. That is about a 8 to 1 aspect ratio. Whoa. Spiral with a lowercase bc, 75 million light years distant. It's almost difficult to figure out how they would have figured out the morphology of a galaxy that presents such as this, visible right about there, if indeed it is almost purely edge on. NGC 1888 is a galaxy in Lepus, magnitude 11.9, 3.2 by 1.2 arc-minute, spiral with a bar and peculiarities. 115 million light years distant, puts it at about over 100,000 light years in diameter. We're at minus 11.5 degrees in declination, and I am definitely making that galaxy out right there. Quite amazing, actually, that we're seeing so much, but I am being selective about how bright and large the galaxies are tonight. Okay, we're going to have a look at a nebula in an open cluster, NGC 1893. And then what I'm going to do is revisit a few of the previous galaxies if I can remember some of their numbers. But I was selective about them, so they should pop. NGC 1893 is a nebula in an open cluster in Auriga, magnitude 7.5, 11 arc-minutes in size with some 60 stars, the brightest of which are magnitude 9.3. It's a middling cluster with moderately disparate magnitudes and moderately disparate spacing. However, it is quite distant, 10,700 light years. We're at plus 33.5 degrees in declination. There is our look. Well, assuming the sky hasn't changed much, this is NGC 1819. I believe we imaged it earlier. It's a galaxy in Orion, magnitude 12.4. 1.7 by 1.2 arc-minute, spiral with a bar, lenticular class, 200 million light years distant. I do remember that. We're at plus 5 degrees. The only difference now is we have imaged in color. So it'll be very interesting to see if there's any distinction made in its morphology and brightness as a result of getting out of IR optimization mode in black and white. And it looks pretty decent in the handheld camera, but then again, it's a magnitude 12.5 galaxy, so let's move. NGC 1832's, I believe, is that galaxy in Lepus the Hare, magnitude 11.3, 2.3 by 1.5, almost oblately presented, spiral with a bar and a lower BC, with a ring, 85 million light years distant, almost minus 16 degrees. I can't tell much. It looks pretty present on the Handycam screen, so don't think we're really losing much. In fact, well, we are seeing 12th magnitude galaxies tonight, but we just weren't getting as good a view as the previous night, it seems to me in recollection. NGC 1888, that galaxy in Lepus. Once again, this one's brightish, magnitude 11.9, and largish, 3.2 by 1.2 arc-minute, spiral with a bar and some peculiarities, 115 million light years distant. We're at minus 11.5 degrees in declination. I do see it on the Handycam screen. Not sure if we imaged it before or not, but it certainly should have been imaged. Moving on. And why not? A globular cluster, NGC 1904 in Lepus. It's also known as Messier 79. Brightish, magnitude 7.7, 7.8 arc-minutes in size. The brightest stars are magnitude 13.1, and we're seeing quite a few of them on the screen. It's a class 5 of 12, 41,000 light years distant, but we are at minus 24.5 degrees in declination, and that is our view. Not sure we're going to see anything here. NGC 1909 is a large nebula in Eridanus, 180 by 60 arc-minutes. Reflective type, 900 light years distant. This baby, in the next maybe 100 million years, will make for a very nice open cluster. We're at minus 7 and change degrees in declination. Thought I'd throw this one in. NGC 1924 is a galaxy in Orion, magnitude 12.5, 1.6 by 1.2 arc minutes. Complicated. Spiral with a bar, but also lower BC in a ring. 112 million light years distant, and I would assume if we were operating at 75x rather than 150, that ring on a moonless night, reasonable transparency, would be visible on this galaxy because it would be roughly magnitude 16.5 to 17, which is just inside the limits. But you know, looking at the Handycam screen, that galaxy is quite present and large. Impressive. 3 bars left on the camera and probably only 10 minutes left on my hands. It's very cold tonight. Well, did you know that Messier 1 is also NGC 1952? A supernova remnant, otherwise known Antares, Messier 1, 6,500 light years distant, 22 degrees, northern declination. You know, it's looking pretty good on the screen compared to the other night. Maybe tonight is extra special transparent. NGC 1954 is a galaxy in Lepus, bright and large, magnitude 11.8, 4.2 by 2 arc minutes, spiral with a bar and lowercase c. So basically 2.5 times removed from Z. 134 million light years distant. We're at minus 14 degrees, hour 5, 32 minutes and 48 seconds, and my hands are probably at about 85 degrees right now. I've selected a neighbor to NGC 19, I believe it was 55 or 56, which is NGC 1957, another galaxy in Lepus because it's magnitude 14.8, a almost perfect 1 by 1 by 0.8 arc minutes, which means one average surface brightness of 1 of equal to the 14.8, add 1.5 to it because we're operating at twice the magnification. And basically we're talking about something in the 16.3 range of average surface brightness. I do believe we picked up a 14th magnitude galaxy previous, but we do not know whether or not that was the blue magnitude or the visual magnitude, which is typically a magnitude brighter than whatever it says on the handset. This is an elliptical galaxy, 147 million light years distant. We're at minus 14 degrees in declination. I hate to shift, but I do believe something resembling, well, these are weird. Maybe there are other galaxies. This is where we've been looking previously. I do believe it's probably on the screen. The stars don't look too distended, and there are some characteristic galactic type signature on the screen itself. So I do not believe that going into black and white mode and turning on IR sensitivity has really helped our ability to peer deeper into galactic space. So I probably should leave it in color mode, and in so doing have a look at what should be a nebula in Orion, magnitude 7, 5.5 by 5 arc minutes inside, emissive type, so it's got a hot bright star in it. 1,600 light years distant, minus almost 5 degrees in declination. There is some nebulosity visible here, but it is not in color. NGC 1973 has a neighbor nebulosity, 1975, in Orion, magnitude 7, 10 by 5 arc minutes, emissive type nebulosity. It's also in the beginnings of a growth cycle. We're at minus 4, almost 5 degrees in declination, moving over. And then, of course, there is this nebulosity in Orion, NGC, I believe it's 1976, otherwise known as Messier 42, a nebula and open cluster in Orion. It's magnitude 4, 90 by 60 arc minutes in size. It is emissive and reflective, 1,300 light years distant. We're at minus 5 and almost a half degrees in declination. And there is our color view. So what I am going to do now is play with the brightness. As you can see what I'm doing here. I can finger it with frozen fingers. What do you got? Frozen fingers. Alright, well, we lost a lot there. Now it does look a little out of focus, but I set the focus up before I did this. The trapezium, of course, is completely overexposed. That's weird. I thought I was pressing the right button here. Okay, 16, 32. I don't like the lack of focus on that though. I don't get that. We are looking at it at 150x. Now that usually amplifies distortions in the atmosphere quite a bit. And then we can completely overexpose it at 256. Okay, I thought we'd have a look at the Conch Shell Nebula, M43, near M42, NGC 1982, Nebula in Orion. Magnitude 720 by 15 arcminute. It's an emissive type nebula, which means it's being ionized by a hot bright star, 1600 light years distant. We're at -5 and change degrees in declination. There's a color view, and it looks quite nice and reasonably well positioned on the screen. NGC 1990s, another nebula in Orion, 50 by 10 arcminutes, emissive and reflective, 1300 light years distant. We're at -1 and change degrees in declination. I do believe some hints of nebulosity are visible around that brilliant star. Well, this shall be our last study of the evening, and no, it is not a galaxy or a nebula of the emissive or reflective type. It is a planetary nebula, NGC 2022, in Orion. Magnitude 11.7, smallest 28 by 27 arcseconds. Good thing we have magnification on this one. It's at +9 and change degrees. Its central star is magnitude 15.8. Should be interesting to see if we can detect it. The planetary nebula is 8,200 light years distant, and as you know, as an amateur astronomer or a professional, planetary nebula are the death throes of stars that don't have enough mass to become novae. Say, stars that are probably 2 to 3 times, nova would be about 10 times the mass of the Sun. But stars that are in the 1 to 2 masses of the Sun, they basically are sputtering and are losing the capacity for nucleosynthesis, but they're hot and they are irradiating their surface gases out into space, taking on the form of a nebula. That is our last view for tonight. Carpe Noctem.